See, and many times in science, by using imagination, you've imagined something which could be, according to all the known knowledge of the laws, and you don't know whether it is yet or not. And that's very interesting, because there's a creative imagination, you like to call it, not just imagining things that are relatively easy, but something different. And to take an example of a star, as we understand it, the ordinary star like the sun, is a great big ball of gas, of hydrogen. It's burning up the hydrogen and so forth, and it's an enormous mass of gas. And it's held together by gravity. You don't have to always understand gravity as curved space. It's good enough for this purpose that force inversely is square of the distance. When things are closer together, the force is stronger. And it pulls everything together. By the way, that's why the world is round, because the globe of Earth is pulled together as much as possible, and if it had a great mountain and an irregularity of a bump, so it would be pulled in by gravity and it all gets smooth. Rocks aren't strong enough to hold a bump much bigger than a few miles, and Mount Everest is our biggest bump. But on the moon, where the gravity's less, the bumps are higher, the mountains are bigger on the moon. Anyway, to get back to the star, it's all held together by gravity, and it's got a nuclear fuel, which we haven't been talking about, that is burning up the hydrogen and generating energy, which keeps things going. And after a while, it would use the fuel up. People began to think about what would happen then. And it would be possible to just be gas sort of hanging around, held together by gravity, but quiet. But another possibility was to think, if I push the stuff together closer, the gravity is stronger. Would it hold together? Well, if you push a little bit together, the pressure increases. When you push gas together, there are more atoms and they pound harder, so the pressure's higher, but the gravity's stronger, and it turns out the pressure wins, so it would just come out again. If you push a star in like that, it oscillates, and there are some stars that are oscillating and vibrating and so on, but it turns out if you keep on analyzing it and you push it together very far to the incredible concentration that the whole mass of the sun is down to the size of the Earth or smaller, then it turns all the nuclear matter, all the nuclei of the atoms are all stuck next to each other tight. The electrons are, the spaces where the electrons are is all squashed out, and it comes out that when you get to that far, the gravity's strong enough, has overpowered the pressure again. Even though the pressure's got to be enormous, the gravity's got to be even more enormous, and the thing will stay steady at a different size and be nothing but a neutron's nuclear matter, nothing, solid nuclear matter. And this is a possibility was worked out by Oppenheimer and Volkoff, and it's called a neutron star. And people waited to see if there were any such neutron stars for years, until recently they found these strange pulsars which emit flashes of radio waves, and later they found light, which can go 30 times a second, for instance, the fastest ones, or maybe 10 times a second, or 1 a second. And at first, that's very mysterious. You're used to stars being big and slow, and how can anything in a star move in a 30th of a second? Well, these things are very small neutron stars, and they're spinning very fast. And there's some, for reasons not yet understood, they're emitting a beam of radio waves, like a searchlight in an airport or something. Those things that go around, boop, 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 so we get the flashes, tick, 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 that fast. To imagine a star, the mass of the sun, doing something, turning so fast as 30 times a second is another one of these big number, hard to conceive imaginary things, okay? And the whole idea that there could be a star of such enormous density that a teaspoon would weigh so much that of the matter that if you put it down on the Earth's surface, it's so heavy it'll just plow right through to the center of the Earth, and things like that. It took a lot of imagination. It comes out of the mathematics and the analysis and all this that helps you to make sure you're not making a mistake. And it turns out that such a star was possible, and it turned out later, in fact, they do exist. And that's a good example of how imagination is a useful thing and produces a guessing ahead of time and how we make advances by using it.